I will present the STORM project. STORM project is an European research project, but don't worry, I will try to be not too much academic. We have different partners in this project from academy, from industry, from organizations. Myself, I'm from ACTIVEEON. It's an open source editor in SophiaConf. We work on a scheduler. And our task in the project is to test the test product of the STORM project on our own software, and also to ensure that the product at the end of the project are not just academic toys, but something that can be really used in an industrial context. So let's start with something you may be familiar with. It's the test pyramid. It's a concept from Martin Fowler. It means that basically you must have much more unit tests, much more automatic tests than you have of integration tests, than you have of functional tests, than you have of manual or user interface tests. You must have much more of unit tests because these tests are more automatic, these tests are less expensive to run, and when you find a bug with unit tests, you can correct it, of course, more efficiently or more quickly. If you overturn the pyramid, what you obtain it's a filter. It's a filter, and the unit test. Every filter is in charge to detect and to detect bugs. The unit test will detect bugs, and the job here will be to improve this unit test to make them discover more bugs and more interesting bug. The job in integration testing will be to automatize the integration testing to be able to test more configuration in an automatic way. And at the end, eventually, even with many filters, you will still have bugs that will stay. And the job here will be to be able to reproduce the bug, because everybody knows, and Martin Fowler also will say when he explains the test pyramid, that the first thing that you need to do when you discover a bug is to have a test that reproduces this bug to be sure that in the future the bug will not reappear. And here we are plainly involved in the DEVOPS process and methodology, because we address the different steps of the DEVOPS workflow. This means that we are interested at the build level to be able to detect if your unit testing are good, and even to produce automatically new unit tests. We are involved in configuration testing. After a build, we are able to automatically produce configuration and to test them automatically. And even at the operation level, we are able to take stack trace of bugs that appear and produce the tests that correspond to this stack trace. And not only that we are different tools, but also these tools are integrated into your best friend, your DevOps tool, your continuous integration and continuous delivery tool. And we'll see how they are integrated. So the tools I spoke about are Descart, that will test your test. Dspot, that will amplify your test, that will produce new tests starting from your test. That's one. It's one issue. If you don't have already unit tests, you cannot apply tools like Dspot. Other tools, you don't need them. For CAMP, for instance, you automatically produce configuration amplification, and we start here with Docker files and Docker Compose files. For EvoCrash, you don't even need tests at all. You start with stack trace and you produce automatically GUnit tests. And you can use them directly, but also, as I said, they are integrated into your favorite DevOps tools. And the tools will amplify your test practice. STORM means software testing amplification. So let's start with some academic point of view still. The basic idea is mutation. Mutation is a way to a mutation is a change in your code, in your source code. Here, for instance, since you are very good, you have already seen the source code. There's a bug. Yeah, you have already seen it, and you have some mutation you can apply on this source code. For instance, you can replace plus equal 3 by minus equal 3. You can even remove because it's a void method, so you can remove the whole body of the method, and so on. Or you can replace 3 by ink if you have already found the bug here. This idea of mutation and the idea of mutation testing is not so old. It's about 2006. And if you want to have a very good point of view or how to apply mutation at a very, very high scale, you have the step of mutation testing at Google to show you how to apply this in a very, very interesting scale. So how mutation works and how we can use them. So you have two tools that operate in a symmetric way. The discard takes your source code and modify automatically your source code. And it takes your test that you already have and applies the test on the mutation. And the idea here is if the test is able to detect, is able to kill a mutant, it says that the test kills a mutant, it means that the test is able to find a bug. Because if you have removed the whole body, of course, if you have removed the whole body of your method and those tests still pass, it's maybe not a so good test. And the result is your test is good. We obtain, in fact, a mutation score that is additional to your coverage score, of course. You still have the both. And it says if your test suite is good enough. And for the despot, it's the reverse. You take the test, you mutate your test, and you evaluate if you improve your code coverage, or you improve even your mutation score. And then you obtain new test. Of course, this mutation must be a bit more smart than the brute force discard approach, because you have to add things in your test like detecting an exception or something maybe a bit more smart than remove the whole body of your test. Will be not very efficient, of course, but still it works. The CAMP configuration testings takes your Docker file. And your Docker file, you have, okay, I have this operating system, I have this version of JDK, or I have I have a Docker compose file with this database, this service, and so on. And automatically, it produces new Docker files or new Docker compose files. With a new version of different version of JDK, different version of operating system, and progress. And this is particularly useful if you are like us, if you are a software editor, because you don't know on which system, with which database, your client will use your own software. But they still need to have it working properly. So if we are not able to test all the configuration that will be used by our clients and our potential clients, so having this good coverage is very important, because if you don't operate your own system, you don't know that, for instance. And you have the test case that will be applied on it. The big scenario, yes, as I said, is to have all these tools integrated into DevOps approach, and all the DevOps tools, so all your tools about source code management, your tool about deploying, about managing the computing resource, about your continuous integration, and etc. So, and even in operation, about your scheduling, your swarm, and so on. So to have the best possible integration. For instance, the despot, you can use it with Eclipse, so it's an Eclipse plugin. You can you have also Gradle plugin to use it in IntelliJ if you prefer, for sure. And you can use it then directly and to obtain your new test and to see if this test can be applied and can produce what they produce and what will be the result of this new test. For the desk card, the best way to integrate it into Jenkins, because it produces you a report. It produces you source code, of course, but you don't need to see the source code. You don't need to see the mutants. Can you give you some information, of course, if you want to see them? But the most interesting thing is the report and the score at the end. And the score here is a mutation score. So you will have here, for instance, you have something that seems good coverage, but if you look more in depth, you see that your mutation score is not so good. So you may look, and of course you have mutation score per test suite, per method, so you can see if each test method is good or not. So you can use it directly in Jenkins and even with Jenkins pipelines. To use Comp, also it's also integrated into Jenkins. And what is nice here, because you start with Docker file, we all know that Docker for testing is very nice because it provides you isolation. And if you want to test the whole system, because here we run system test, it's good to have an good isolation to run them and to run in different instances of them. So Docker here is used both as an input to describe your system and to obtain different variations of your system, and also to run the test in a different way, in a different environment. And especially in ACTIVEEON, we are in charge to automatically build the workflow that will deploy the different configuration and to test the different configuration in the more automatic and fluent way. And Evercrash, I will not just say use the theory behind Evercrash because it's quite complex. It's about genetic algorithm. Maybe some of you know about that. But anyway, what it does, and this is an example coming directly from our production logs. We have a stack trace that comes from a client that uses our platform. And it give us a stack trace, and we apply it on Evercrash through the Gradle plugin that we have ourselves down, and it gives us the test that correspond to this crash. And now we can save hours of investigating, of finding why is where this bug coming, especially because, again, we are editors, so our client use our software. We get information about the crash, but not more. Only the stack trace can have more information, and we don't have their access to their particular environment and their particular data. So it's hard to reproduce. So it's very useful in many cases, and especially in our case. Also, we use it in our try environment, which allows a client or potential client to use our platform online. So here they use it, and they use it in a many different way. So it's able us to detect more use case than our clients that already have. So now what you have Stomp in many different steps of your continuous delivery pipeline, and you can use it at different steps and all the tools of Stomp. You also can try Stomp in a virtual lab. It's available. And you can have more information. You can see on the website. You have these very nice flyers, if you want to have them, about the project, and you can use it and try it. Of course, everything is open source and all available in GitHub.
Just to make sure I understood correctly, you did not say it explicitly. It's working in only on the JVM languages.
Yeah, it's only working in Java because of course, the mutation it's you cannot have you can have quite generic mutation, but still, the tool is at this moment for units and also for every crash. Also, you have a stack trace. For comp, it's a bit different. Comp can be used in a different system than Java. It's just rely on Docker. So if you have a system test, it can be whatever way to call your system test, you can use it. But the 3 over, yes, it's
And
so to be quicker, it's work only on Java except for comp, which we only use Docker, which is agnostic, but the 3 over, are based on Java.
Do you know if something equivalent exists for other languages, Python, C++?
There exists mutation testing tool for C++, but we don't have integrated yet into our own tools.
Thank you.
And also for core dump, you can even take core dump instead of Java trace to use.
Thank you. So my question is, can we configure to use only one option, like discard or despot, or it is a set of?
No, each tool is independent. For instance, we use mostly we use Evo Crash and Comp in production now, but we don't use Despot in production, but you can use them standalone or with command line, independent. It's totally separate.
And for just for testing tests, is it sometimes we lose time when we test our tests? For the first option, I'm wondering if it's not consuming time when we test our test.
It costs time. It's why we integrate this tool into Jenkins and so on, because these are quite advanced techniques. So creating the mutants, and applying the test on the mutants to see if it kills them, it's quite time consuming. So Despot, maybe it's more quick, so you can use it directly on your IDU, and but Overtest must be integrated into a continuous development server that will run them and will give you the report in someday. And someday, no, not someday, but in some hours, maybe every day.
So it's available as open source. Very good. We have a question over there.
I was wondering, for example, in IntelliJ, you can do something like a plugin. So if you modify a line of code, automatically detect some test is going to fail because of that. Basically, what you did is an automatic mutation. But imagine changing the code live, and what you did could detect a failed test because of the change.
You need to repeat the question.
Effectively, it can detect. It detects automatically, but you do the mutant. You create the mutants. So it's a bit the same idea, but here we create automatically the mutants. So we flush the code and we modify it continuously to detect. But it's a bit the same idea. Yeah. Yeah, it's another to say, okay, to have a relation between the code and the test to see which line of code affects the test. Here it's more broad and we don't have this knowledge before we just run the test quite brute force way.
Thank you very much.